All right, we are now ready to do the rest of page 133. And we are going to, so we did these four little examples up here where our common factor was a binomial. We took it to the outside and we created a multiplication problem that involved two binomials. So down here, we are going to, first of all, we are going to factor by a different method by grouping because we have four terms now. So we haven't had four terms before, but we do now, and we are going to have a process, and you can look at these steps, and I'll talk you through them. I'm not going to read them to you because you can read them on the page, but we'll work through these examples, these two examples at the bottom, and I think you'll understand the process, but the process is documented here for you. One little note before we go on, because this is going to become important to you. When you see x plus 3 and 3 plus x, you need to just understand, of course, that these are equivalent. They're the same. They're equivalent expressions. Because when we are adding two terms, the order doesn't matter. So this was the commutative property of addition that we studied last year. But this is different down here. When you're subtracting, the order does matter. And these guys actually turn out to be opposite expressions. And you can see that if you plugged in, let's say if we plugged in 2 for x and we had 2 minus 3 and we had 3 minus 2, this would be minus 1 and this would be positive 1. And those are opposites. So when we see these expressions that look like this, we're going to just know in the back of our head that they're not the same, that they're opposites. And I'll tell you what you're going to do with that when we get there. So let's look at these two examples. We're going to notice that we have four terms here, and our process says underline the first pair of terms and underline the second pair of terms. So let me go get red for the first two and green for the last two terms. And then we're just going to concentrate on these first two terms initially. What do they have in common? They have a 2 in common. The GCF is 2. So we're going to factor out the 2. And now we're going to move on to the second pair of terms. When you have a negative sign down here, you are actually factoring out a negative GCF. So what do you see that they have in common, these two terms? They have a D in common, and we are factoring out a negative D. So that leaves a positive C on the inside. And notice that the sign here changes. And the way that you can tell if you've done this correctly is go ahead and in your mind distribute this guy back. Minus D times C is minus CD. And a minus D times a plus D gives you this minus D squared. So this negative sign here can trip you up a little bit, but if you'll take the time to distribute back, if not on paper, certainly in your mind, you can see that you've got the correct thing. Now, one more step. We have two terms here, and we have something in common. It's this binomial, which is exactly what we did in these examples back up at the top of the page. We factored out a binomial that they have in common. So C plus D comes to the outside, and what's left on the inside term is 2 minus D. This sign right here, and we've taken away the C plus D, we've divided it out of each term. So this is our answer. So basically we're using what we learned in the first couple of problems at the top of the page, but we're doing one extra step. We're solving by grouping the first two and the last two sets of terms together. So if you notice, what do these guys have in common? They have a U. When you factor the U to the outside, U to the first minus 3V is left on the inside of that grouping symbol. Again, we've got a minus sign, so we're going to be careful here. With the second term, we are factoring out a negative 6. Note they have a 6 in common. And they also have a V in common. Oh dear, I have to make room for my 6V. Let me go back. Oh, now I lost the blue pen. Oh well, we'll go with green. All right, so we're going to factor out a negative 6V. What's left on the inside, that first term is just the U. and what's left in the second term is a negative 3v. Prove it to yourself. Minus 6b times positive u is minus 6uv. And a minus 6b times a minus 3b turns that positive, which is what we need. 6 times 3 is 18, and v times v is v squared. So there's no way you can miss these if you take time to do your distribution back in your head. One more step to finish it up. We have a common pair of terms. So we have this binomial, u minus 3v, remembering that these parentheses are really important. You change the whole problem if you leave the parentheses off. What's left in this first term when you divide out the u minus 3v is a u to the first power, and in the second term what's left is a 6b, and it's minus. There's the sign. So that's the factored out answer for example 6b, and I will see you on the next page.